Hey kids, today we're going to look at the arc sine of a function and try and find the derivative of this bad boy. So with your arc sine function, you've got a really specific pattern, and if you're one of my students, you've got this cool yellow sheet, and on that cool yellow sheet are all your different ways to find derivative. And so if you don't have a cool yellow sheet or you're not one of my students, it's really a good idea while you're trying to learn all these derivatives, if you can just write down what these different derivative rules are, just write them down so that you can see them and refer back to them, and that'll help kind of guide your thinking while you're working on your homework. So what we're going to learn from this is that if you were to take the derivative of the arc sine of u, that's going to be equal to d dx arc sine u. That one is just really shady. Let me make him a little cleaner. So it looks like this, arc sine of 1. And the pattern for that is going to be 1 over the square root of 1 minus u squared times du dx. So this is your derivative rule for arc sine. It's not really hard, except we don't have a u in our arc sine. We got this other thing, this 1 over 5. So this guy right here, 1 over x to the 5th, that's going to become my u. And I'm going to rewrite it as x to the negative 5th. This is totally legal following my rules of math. So du dx is equal to negative 5x to the negative 6th power. And I'm going to leave it like this for a little while. I might change it back, I might not, I don't know. But this is a good derivative right here. And then for my y part, y equals arc sine of u. And with arc sine of u, I'm ready to go with my derivatives. So dy dx is equal to arc sine of u. What is that? That's going to be 1 over the square root of 1 minus u squared times du dx. And so with this 1 over 1 minus u squared du dx, I'm just going to substitute in all of my u's now. So I end up with 1 over the square root of 1 minus u, 1 over x to the 5th squared, times du dx. So that's going to be times negative 5x to the negative 6th over 1. So when I multiply straight across the top and straight across the bottom, I end up with negative 5x to the negative 6th over the square root of 1 minus 1 over x to the 10th. Wow, that's crazy. And what I do, I just squared out my x to the 5th. So I have x to the 5th times x to the 5th. I get 1 over x to the 10th. The only way that you can clean this up any better and make it even a little bit more presentable to people, some folks like to go ahead and combine like terms in the denominator and clean that radical out. I'm fine with the radical like that, but I would like to see positive exponent if you could. So go ahead and move that x to the 6th to the bottom, and we'll end up with 1 minus 1 over x to the 10th power under the radical. This will be a good answer for me on this question. So here's how you find a derivative using the rules from the inverse trig functions.